Carry on from our previous video, we have discussed the ground improvement techniques. The first we have discussed was soil compaction in ground improvement techniques. In this video, we will be discussing about the second method of a ground improvement technique, that is soil stabilization. Enhancing the soil properties by altering the composition of the soil is known as soil stabilization. Special soil is proportioned, which is added or removed, or a cementing material or a chemical is added to a natural soil. Soil stabilization, which is the second method of ground improvement techniques, can be done by three methods: mechanical stabilization, cementing stabilization, chemical stabilization. The first of the soil stabilization of ground improvement technique, which is mechanical stabilization, we will be discussing about improvement of soil gradation, rearrangement of soil particles, densification of soil, correct proportioning of coarse and fine grained soils, well proportioned coarse material containing some clay binders. For relatively high density, the particle size distribution flow, the formula for that is percentage passing any sieve equals to 100 under square aperture size of the sleeve by size of the largest particle. Greater proportional of material less than 0.07 mm is necessary for adequate cohesion. Lab test and suitable properties: particle size analysis, plasticity test, constituency limit, compaction test, plasticity index, base should be maximum of 6%, surfacing should be maximum of 4 to 9%. Liquid limits: base 25%, surfacing 35%. Cement stabilization, which is the second method of soil stabilization under the ground improvement technique. I would like to repeat, cementing stabilization is type of soil stabilization under the ground improvement technique. In cement stabilization, binding of soil particles without altering their gradation. We use Portland cement or bitumen or asphalt or lime. Talking about cement stabilization, more of coarse grained particles are cemented. Properties depend upon nature of soil, type of amount of cement used, placement and cure condition adopted. Suitable for base of the road or airfield. It means cement stabilization should be used in airfields or road where the soil bearing capacity of the soil is not achieved. I repeat, cement stabilization is one of the types of soil stabilization which is under ground improvement techniques. These are the various parameters of soil or cement which can be used in cement stabilization. Soil should be well graded soil, maximum size 75 mm. Not greater than 50% should be passing by 4.75 mm sieve. 50% should be finer than 0.07 mm. Plasticity index should be less than 20%. Liquid limit should be greater than 40%. Cement used by weight of 5 to 20%, for gravels 5 to 10%, for sand 7 to 12%, for silts 12 to 15%, for clay 15 to 20%. Moisture content, two roles: influence compaction characteristics, cement hydration. Construction methods: shaping the soil, pulverizing the soil, adding cement, dry mixing, then adding water, then mixing, pulverizing and grading, compacting, finishing and curing. These are the various pictures which you can see on the slide where stabilization process is being used in ground improvement techniques. One of the methods of soil stabilization is using of bituminous soil stabilization. Stabilizes soil by binding the particle together and then making it waterproof. For best results, these are the parameters which should be adopted. Maximum particle size should be less than 1/3 of the compacted thickness, greater than 50%, finer than 4.75 mm, 5 to 10 to 50% finer than 0.07 mm. Liquid limit should be less than 40%. Plasticity index should be greater than 18%. Asphalt should be immersion in water. The method of construction should be pulverization of soil, adding of water for proper mixing, adding asphalt, emulsion, mixing, pulverization and grading, compaction and then finishing. Chemical stabilization, which is the third method in this soil stabilization, which is under the subheading of ground improvement techniques. In chemical stabilization, bonding of soil particles with a cementing agent produced by chemical reaction with or within the soil. Chemicals are also used as a secondary additive to increase the effectiveness of cement and bitumen. Common chemicals which are used are lime, calcium and sodium chloride. These are the common chemicals which are used in soil densification. Natural and synthetic polymers which are powder or liquid, water soluble. Waterproofing materials. Lime stabilization. Slaked lime is added to reactive soils. Polzonic reaction happens. Stable chemical silicates and chemical aluminates. Formation of a strong bond between the clay and the soil particles. Long-term strength gain. New bases as well as reculmination of the bases, ineffective for granular soils. Processing and curing. Lime treatment material requires 5 to 7 days. Cement treatment requires only 2 days. A combination of lime and cement stabilization can also happen in 2 stages. Stage 1, 1 or 3% of the lime is added, then mellows the plastic clay 24 to 48 hours, then plasticity decreases significantly and soil becomes friable. Stage 2, pulverization, adding cement, mixing, pulverization, graining and then compaction. Stabilization results in an improvement of reduction in plasticity index, increases CBR, which is California bearing ratio, increase in maximum dry density, significant increase in UCS, which is unconfined compressive strength. These are again some of the pictures which are shown in front of you, which shows stabilization process. In this video, we have discussed the second part of the ground improvement technique, which is soil stabilization. In the next video, we will be discussing on soil densification, which is the third type of ground improvement techniques. Thank you and Jai Hind.